So we're going to be going over impulse and just understanding the equation. So we're going to start really quickly with Newton's second law. Force is equal to the mass times the acceleration. And you probably already know that acceleration is equal to the change in velocity over the change in time. And this delta sign means final minus initial because that's how you get the change. You also know that just by rearranging this equation and solving for acceleration, we get force over mass because you have F equals ma. If we want to find A, we just divide by m. So you can kind of ignore this average here for now. Now, knowing these two things, they're both equal to acceleration, so we can set them equal to each other. And that's where we have force over mass equals the change in velocity over the change in time. Now you can rearrange this equation even more by moving time over to this side, by multiplying it out, and then doing the same exact thing with mass. And when you do these two things, you get this equation. This is force times the change in time is equal to mass times the change in velocity, where if you write that out, let's see, we have mass times the change in velocity. And since velocity is Vf minus Vi, we have mass times Vf minus Vi. And then you can distribute the mass out. And when we do that, we get mvf minus mvi. This is a really important equation and probably the one you want to take away from this video, because momentum is p, and p is equal to mass times velocity. So what we have here with the final and initial values is then the change in momentum, and it's equal to the average force times the change in time. And what these two values are equal to is impulse, which is J. And what this equation then tells us, because they're equal, is that impulse equals the change in momentum. And the reason that it exists that way is because impulse is what causes momentum. So by Newton's third law, there must be conservation there. So whatever force is acting on an object, that will be the change in momentum that the object has. So knowing this, you can play around with these things. You can say impulse equals Pf minus Pi. The reason that you can say that is because we just said here that this is impulse, so that's J. And we also said that P equals mv. So we have the change in momentum here. This is the change in momentum. Doing Pf minus Pi is equivalent because that's how you get the actual change. So this side is this side of the equation. So depending on what problem you're given, you can use these different equations. If you had a problem that gave you mass and velocity, you'd use this. If it just gave you momentum, you'd use this. Things like that. There's one more thing I want to show you, and that is knowing this equation, you can rearrange it. So if you have initial momentum and impulse, but you don't have a final momentum, you can just rearrange this equation. And for example, here, all we had to do was add initial momentum to both sides. So then we get Pf equals Pi plus J. And you can do the same thing here. Just move variables around. So that is what you need to know for the very beginning of momentum. And I think it also will help you visualize how things like mass and velocity equal momentum and how you can use that to find things like impulse.